The next problem that we are trying to solve is 3 strings problem. Easy. It's a problem from Codechef Starter 221. Alright. So in this problem, we are given 3 strings: string A, string B, and string C. All 3 are binary strings, right? They are asking us to find the minimum number of operations needed to convert this B string equal to this C string. In order to do this conversion, there are some types of operations given. First type is we can flip a character in string A or string B. Okay, that is a cost of 1, right? Each operation we do has a cost of 1 unit. All right. Second type of operation is if we pick two indices I and j, then if ai is double equal to aj, then bi can be swapped with bj. Okay. Using these two operations, they are asking find the minimum cost of converting b string equal to c string. Now here, this second type of operation does not have any cost. We can perform any swap operations we want. Now, using these two operations, how will we minimize is the question. All right. So let's look at the input given to us first of all. In this input over here, we are given 3 strings. In these strings, let me write indices 0, 1, 2, 3, 4, 5, 6, 7, and 8. Index 0 is already matching, index 1 is already matching, index 2 is already matching, 3 is already matching, 5 is already matching, and 8 is already matching. So we don't need to worry about those indices which are already matching, because if we change them or if we make any flip operation, then we will basically lose an already existing match, right? We actually want to match every single index. The ones which are already matched, no need to make any changes in that. So we only need to make changes in the ones which are not matching. Like for example, index 4. Index 4 is not matching, index 6 is not matching, and index 7 is not matching. So these are the indices which we need to work upon. Okay. So firstly, let me write down all the configurations that we'll encounter in any strings that they'll give us. These are the configurations. 0, 0, 0, sorry. 0, 0, 1 is one configuration, 0, 1, 0 is another configuration, 1, 0, 1 is another configuration, 1, 1, 0 is another configuration. Okay. I call each of these configurations as x1, x2, x3, and x4. Okay. For now, let's not focus on this thing that I've written, x1 minus minus and all. Okay, let's not focus on this right now. We are having 4 configurations with us: 0, 0, 1, 0, 1, 0, 1, 0, 1, 1, 1, 0. These are the configurations which need to be changed. Okay, in all other configurations, change is not necessary because B and C values will be the same in other configurations. So I've only written those configurations which need to be changed, which need either flip operation or swap operation, whatever. Okay. So now, if I want this B to become equal to 1, like over here I want this guy to become 1 and this guy to become 0, only then this 0, 0 will match and this 1, 1 will match, right? If I want this match to happen, we can actually make use of the second operation that we know. What is that? As a of I and a of j are same, we can swap this 0 with 1 and we'll get 1 over here, 0 over here. And that's how index 0 or the first character of B string and C string matches. Similarly, second character of B string and C string also matches, right? So this swap operation can be performed. Okay. But in order to do that, we actually have to understand what actually happens when we perform the first operation on the string A or the string B, right? Like for example, here this was 0 and this was also 0. That's why we did this swap operation. What if this was 1? If that was 1, then we could not do the swap operation, right? Okay. So we know that how swap operation works. Okay. Don't worry about this x minus 1, x3 plus plus, all this not required right now. Okay. Coming down forward. Now, here we know that x1 has a configuration, x2 has a configuration, x3 is representing a configuration, x4 is representing a configuration. Now, we have seen here that if this 0 and this 0 are same, then the 0 over here can be swapped with the 1 over here, and basically first character of B string and C string will match. Similarly, second character will also match. It means x1 configurations and x2 configurations can actually swap the bth character, the character in B string, right? Okay. It means if I have, let's say, two x1 configurations 0 0 1 0 0 1 and two x2 configurations 0 1 0 0 1 0, then this guy can be swapped with this guy, the first guy can be swapped with the third guy, and the second guy can be swapped with the last guy, right? It means we need equal number of x1s and equal number of x2s. X1 and x2s should be in equal number. Then we can actually swap the character from the B string with the character in the C string, right? So that's how we got the formula x1 should be equal to x2. Okay. Similarly, if you see this configuration x3 and x4, in this also character string A has the same character A 1 and 1, right? It means B string can swap with the C string, right? Here we get a 1, here we get a 0, so 0 0 matches, 1 1 matches. Okay. So it means there should be equal number of x3s and equal number of x4s. Only then this swapping will lead to correct answers, right? Will actually lead to B string becoming equal to C string, right? So here I have written x3 to be equal to x4. These equations can also be rewritten as x1 minus x2 is equal to 0 and x3 minus x4 is equal to 0. Now this difference x1 minus x2, I am denoting that with d1. x3 minus x4, I am denoting that with d2. Okay. Now we are thinking, what if d1 is 3, where you are subtracting the number of configurations of x1 and a minus number of configurations of x2 and you got 3 as answer. Similarly, when you find a d2, x3 minus x4 is giving you minus 4. If this is the configuration you have, then how will we actually solve the problem? Which operation should we apply? Should we apply first operation? Should we apply second operation? What should we do? To understand this, let's see what happens if I perform first operation on A string. Okay. Alright. So if I want to perform my first operation on A string, what does first operation say? It says flip 0 to 1 and 1 to 0. Okay. So if I perform flip operation on A, then this guy will become 1. Right. So it means 0 0 1 is becoming 1 0 1. Right. The number of x1s are getting reduced and the number of x3s are getting increased. That's why I have written here x1 minus minus x3 plus plus. Okay. Similar to that, if I perform the first operation on the second character over here, on the second character of A string B string, on the second character of A string, then initially I have 0 1 0, but after flipping the 0 it becomes 1 1 0, right? The number of x2s are getting reduced, the number of x4s are getting increased, right? So that's why I've written x2 minus minus and x4 plus plus. Similarly, when 101 is the string configuration and we perform the first operation on the string A, right? Then what will happen? Then 101 will get modified to 101 will get modified to 001. It means x3 minus minus will happen and x1 plus plus will happen. That's what we have written over here. Right? Similarly, if you do the operation on the last configuration x4, x4 count will get reduced and x2's count will get increased. That is what will happen. Okay. Alright, so this is what is happening when we do type 1 operation on string A. That is very clear. Okay. What would happen if we do it on string B? Let's see that. Let's say you have a configuration 0 1 0. Okay, if you have 0 1 0 and you perform first operation on string B, this is string A, this is string B, this is string C. If you perform first type of operation on string B, then 1 becomes 0 and there is a match found, right? It means performing the operation directly on string B creates a match, right? Very good. Moving forward, we have understood one thing, that we need to find x1 minus x2 equal to 0, x3 minus x4 is equal to 0. We have named them as d1 and d2 so that we can solve problem easily. Okay, understood. So now d1 is 3, d2 is minus 4. These are assumptions. I've taken a random value for d1, random value for d2, assuming that our x1 minus x2 value is 3 and x3 minus x4 value is minus 4. Okay, now if this is the case, then we need to understand or figure out in how many minimum steps can these two become 0. Okay, now in order to do that, we want d1 to become 0, we also want d2 to become 0, right? Both of them should become 0. In order to do that, in order for d1 to become 0, there are only two things that we can do. Either x2 should increase or x1 should decrease. If x2 increases, subtraction will increase and it will lead you to 0. If x1 decreases, then the initial value itself is small, so anyhow you will reach near 0 or you will eventually lead to 0. Okay. Now let's see what operation can we perform. Can we do x1 minus minus? Yes, there is an operation which can do x1 minus minus. Okay, and when we do when do we perform x1 minus minus? When okay, so x1 minus x2 is leading to d1 and x3 minus x4 is leading to d2, right? Here we want d1 to become 0 and d2 to become 0, right? In order to do that, let's try by reducing x1, right? And when I reduce x1, automatically x3 will increase, right? So which operation are we performing? We are performing this operation, right, where we are reducing x1 and we are increasing x3, right? If we do that, what will happen? x1 minus x2's value will get decremented and x3 minus x4 value will get incremented, right? Over here d1 will get decremented, it becomes 2, and minus 4 will get incremented, it will become minus 3. Again we repeat the same thing, 2 will become 1 and minus 3 will become minus 2. Again we repeat the same thing, 1 will become 0, minus 2 will become minus 1. When d1 becomes 0, we stop doing the same process. Why? Because now if I again do the process, then this will become minus 1, right? We want d1 to become 0, and when it becomes 0, we stop and we say d1 has become 0. In how many steps? In 3 steps, in 3 operations, okay. And what about d2? D2 is minus 1. Now the meaning of d2 is minus 1 is that difference between x3 and x4 is minus 1. It means a number of configurations of x3 minus number of configurations of x4 is minus 1. It means x4 has one configuration more as compared to x3. What is x4 configuration? Let's see. x4 configuration is 110. It's 110. This is extra. We want this guy to become equal to 0. For that we need first type of operation on string B. So we do that, and that's how in one extra operation we are able to make all characters of string B equal to the characters of string C. Total number of operations is 4, right? Okay, let's move forward with a different example of D1 and D2 and see how we can solve it. Here we have D1 as 7, D2 as 4, right? If I do the same process that I've done earlier, then what will happen? 7 will become 6, 6 will become 5, 5 will become 4, then 3, then 2, then 1, then 0. This 4 will get incremented 5, then 6, then 7, then 8, then 9, then 10, then 11. At every step, decrement, increment, every step decrement, increment, every step decrement, increment. And when you do that, when D1 becomes 0, we are already done with 7 operations. And after the 7 operations, D2 value is 11. Now this 11 can be reduced to 0 by using 11 type 1 operation on string B, which total number of operations becomes 7 plus 11, which is nothing but 18 operations. But this is not optimal. Why? Because here we could have done this in lesser operations as well. How? We could have actually used directly type 1 operations on string B. We could have used directly type 1 operations on string B for D1 as well as D2. If we do that, then this 7 would have become 0 in 7 operations. And these operations have not changed the value of D2. So this guy requires 4 operations to become 0. And once all 7 and 4 are done, you get B string exactly equal to C string. It means in total 11 operations, you were able to convert the B string into C string. So 11 would be the answer, right? Okay. Now, how do we decide using this approach is better or using this approach is better? Here we used some type 1 operations on string A. And then some type 2 operations. So not type 2, after type 1 operations, and here then we used one type 1 operation on string B. One type 1 operation on string B. But in the second case, we did not use any type 1 operation on string A. We only used it on B. Why is that the case? Why not use only B in both the examples? Because when we use type 1 operation on string A, what happens is one value gets decremented, x1 gets decremented, x3 gets incremented, x2 gets decremented, x4 gets incremented, which in turn leads to a reduction of D1 and increment of D2, or D1 increment and D2 decrement. Either of these two will happen, right? So at the same time, both of these values are actually going towards 0. Here 3 was moving towards 0, even -4 was moving towards 0. So when both of these are moving towards 0, then performing type 1 operations on string A is better. But over here in the second example, D1 as 7 and D2 as 4, when D1 was moving towards 0, D2 was actually moving away from 0, which led to 7 plus 4, 11, which is 18 operations, right? So in this case, what was better? Performing all operations on string B was better. That will give you 11 operations, and in 11 operations, string B becomes equal to string. Let's look at this D1 and D2. D1 is 5, D2 is -8. If it is like this, then here also if you see, this is positive and this is negative. Positive value, when it moves to 0, it has to keep reducing. -8, if it has to become equal to 0, it has to increase. It means here we can actually perform operation on string A, and when we do that, 5 becomes 4, 4 becomes 3, 3 becomes 2, 2 becomes 1, 1 becomes 0, and -8 becomes -7, -6, -5, minus 4, minus 3. Decrement over here, increment over here, decrement over here, increment over here. This continues, right? So when the operation on string A is leading both these strings, towards 0, then we'll perform type operation on string A, the flip operation on string A. Otherwise, we don't do it. We do directly flip operation on string B. So to conclude this, we can say that if D1 is greater than 0 and D2 is less than 0, then we can perform flip on A. Or D1 is negative and D2 is positive, then also we can perform flip on A. This will lead both of these numbers towards 0. Both of these differences will bring it towards 0. But at the same time, they will not become 0. Either D1 or D2 will become 0. So when any of them becomes 0, then we'll perform flips on B string. Flips on B string will be performed to make sure that the non-zero value, either D1 or D2, whichever is non-zero, that value becomes 0. Okay. For example, over here, if you see 5 and minus 8, 5 becomes 0 in 5 operations. And after 5 operations, our D2 value changed from minus 8 to minus 3. This minus 3 will become 0 in 3 operations. Alright. So 5 plus 3, total 8 operations is enough. To actually solve the problem. To actually make sure that string B is equal to string C. Many of you might have this question. How is this minus 3 value becoming 0 by performing operations on string B? See, if D2 is minus 3, it means x3 minus x4 value is minus 3. It means x4, there are 3 x4 values which are x4 configurations which are more as compared to x3, right? The number of configurations of x4 are 3 more than x3. That is the reason it is minus 3 over here. What is x4 configuration? It's 110. So here we have 110, 110, 110, which are extra, right? Now to make these two equal, B and C string to be equal, the only option possible is convert this 1 into 0, convert this 1 into 0, convert this 1 into 0. For that, we need type 1 operation on string B. That's why we need 3 operations over here. Okay. So total 5 plus 3, 8 is the answer. Now when should we perform only flip on B operation? Whenever this condition is false. If T1 is, like for example, if T1 is 0, D2 is 10. In this case, this condition will fail. We'll only perform type 1 operation on string B, right? If we do D1 is minus 10 and D2 is minus 4, here both are negative. Still, they do not follow this condition over here. Hence, we only perform type 1 operation on string B. Okay, so that D1 becomes 0 first and then D2 becomes 0. In total 14 operations, they will become 0. Okay, this is how we solve the problem.